Welcome to this video from the RC Ground School. In the videos in this topic, we'll provide a brief overview of three important components of an electric model's power system. These include the motor and ESC basics, propeller and EDF basics, and finally, battery basics. As with all the videos in this series, we've touched on some aspects of these topics already, but in this set of videos, we'll dive a bit deeper. Let's start with motor and ESC basics. For a motor to spin, electrical current in the motor windings is reversed many times per second to cause a push and pull effect on the magnets mounted either on the motor shaft or on the motor's bell. Brushed motors use a split ring on the motor shaft and small metal strips called brushes to switch the current flow mechanically. This is called commutation or using a commutator. By changing the current flow, the magnetic polarity changes from plus to minus or vice versa. These motors are not very efficient. Most new electric models use brushless motors to spin their propellers or EDF units. Brushless motors don't use brushes to change the flow of electrical current necessary for the motor to rotate. Instead, brushless motors used in model airplanes use external electronic speed controls to control how fast the motor turns. The speed control uses sensitive electronic components to determine where the motor windings are in relation to the magnets and sends current down the correct motor lead to change the magnetic polarity to push the magnet away from one magnetic pole in the motor and to attract it to the next pole. Remember, like magnetic poles repel each other and opposite magnetic poles attract each other. The sensors manage the push and pull of the magnet's poles to cause rotation and to manage how fast the motor spins. This is why you can change the direction a brushless motor rotates by simply changing the connection of any two of the three wires leading from the ESC to the motor. As the motor spins, the movement of the magnets produces a very small electrical voltage called back electromotive force. The electronic speed controller senses this voltage and computes where the magnets are in relation to the motor's rotation. This information is used to send the proper current down one of the three leads that comes from the ESC. The ESC changes the electrical polarity by reversing the current flow and the motor rotates. This equates to the commutator of a brushed motor, but is much more efficient. It's important to understand that motors have electrical limitations. Motors have limits on how many amps of current they can handle and how many watts of power they can be asked to safely produce. Exceeding these limits can cause motors to overheat and the windings to short out. Motors are also designed to produce more speed, more torque, or some predetermined balance of the two. Motors that are labeled with a low kV rating produce more torque. Models with those motors usually have large diameter and high-pitch propellers. kV means revolutions per volt. Motors that are labeled with high kV ratings produce more speed and are often paired with smaller low-pitch propellers. Motors used in electric ducted fan models usually have high kV ratings. The propeller is the primary resistance variable in the electrical circuit. Too much resistance can result in overamping the motor or exceeding the watt limitations. Be mindful of this when changing propellers on electric airplanes. ESCs also have electrical limitations. Normally, the primary limit you will want to be mindful of is voltage. ESCs will specify how much voltage they can safely accept. Excessive amps or other motor faults may cause the ESC to overheat. Many ESCs have thermal protection circuits that will cause them to shut off before they're damaged. ESCs often include battery eliminator circuits, or BECs. Most RTF and bind-and-fly kits will include ESCs with BECs. A BEC is basically just a voltage regulator that outputs the voltage required by receivers and servos. BECs allow you to power your receiver and servo using the model's main battery instead of the added weight of a separate receiver battery. Alternatively, a separate receiver battery can be used, but small models almost always use ESCs with BECs. BECs may continue to work even if the ESC shuts down to overheating. Loss of the BEC portion of the ESC, or even a separate standalone BEC, will result in loss of model control. If this all sounds like gibberish to you, you may want to study up a little on Ohm's law and how amps, volts, resistance, and power are all related. This won't matter if you're flying a model as it comes out of the box. The manufacturer did all the computations for you. However, as soon as you start doing things like changing props or adding bigger batteries, you'll want to know how your changes will impact your power system's components. In the next video in this topic, we'll take a look at props and EDF units. As we close this video out, if you found it helpful, please click on the thumbs up icon and subscribe to the RCPlaneviews.com channel. Click the bell icon to be notified when I post new videos. Thanks for watching.